Now in this module I want to discuss chemical equations. Now the main one I want to discuss is how to balance an equation. This is a chemical equation here. What this says is that one molecule of sodium combines with one molecule of chlorine to make one molecule of sodium chloride. Can you see that there? Now why does it take only one molecule of each? Well, the best way to explain this is by looking at the periodic table. If you look at the row that the atom is in, it will tell you how many electrons are in the outer shell or the valence shell, or how many it needs to fill the outer shell. So if they're in this row here, you can see they need one electron in the outer shell. And if they're in this row here, they have two electrons in the outer shell. Remember I said before, if they're in this one, they need one electron in the outer shell. So wherever it is in the outer shell is the combining power. So as you can tell, sodium is in the first row. It's got one electron in the outer shell. Chlorine has got 7 in the outer shell. It needs 1. So do you see why they combine with it? Equal 1 and 1. Chlorine needs 1. Sodium's got an extra 1. That's why they combine with a power of 1, 1. Let's look at this one here. Carbon and oxygen. C plus O2 give you CO2. What does this tell you? Well, it tells you that one molecule of carbon combines with one molecule of oxygen, which has 2 oxygen atoms. Don't forget it's a molecule of oxygen, but it's got 2 oxygen atoms to form one molecule of carbon dioxide. Why does it take 2 oxygen atoms compared to 1 carbon atom? Why? Well, if you look at this here, that's something here. It tells you here carbon needs 4 electrons in its outer shell, whereas oxygen needs 2 in its outer shell. That is why it takes 2 oxygen atoms to combine with 1 atom of carbon. To fill the shells, you need twice as many oxygens because they've only got 2, and the outer shell and carbon needs 4 electrons. That's why it combines at a ratio of 2 to 1. Can you see there? 2 to 1. When they combine, they share electrons, and all have got full outer shells, and therefore they are stable. This is why carbon dioxide is stable, because it's got a full outer shell. Now, do you understand how atoms, to combine to form molecules, they have to do this, they have to fill their outer shell. And this is the foundation for chemical reactions. Let's look at this here. This is showing you CO2. There's the 2 oxygens at the top. They've both got 2 valences in the outer shell. The carbon at the bottom's got 4. When they combine, watch this, they combine like this. There you go. That is carbon dioxide. If you look, all of those outer shells are full. All of them have got 8 in their outer shell. That is a molecule of carbon dioxide. They are sharing electrons. Let's look at another example. Hydrogen plus oxygen give you water. 2H2 plus O2 give you 2H2O. This is the balanced equation of hydrogen and oxygen to make water. Why does it take twice as much hydrogen as it does oxygen? Well, look at the valence. Look at the valence shell, where they are in the periodic table. Hydrogen is in this row and has a valence of 1. It's got 1 electron in its outer shell, and oxygen's got a valence of 2, and it requires 2 atoms to fill its outer shell. Therefore, to combine, it takes 2 hydrogen atoms to 1 oxygen. There, can you see that? This can be shown here. This is a hydrogen atom. It's got 1 proton, 1 neutron, 1 electron. We've got 2 hydrogen atoms. This is an oxygen atom. As you can see, it's got 2 spare places in its outer shell that need filling. When they combine, they share electrons to fill their outer shell, as you can see here. That's how they combine, and that is H2O.